Hello students, how are you? This is Mahesh Tovaskar. You are watching my channel Maestro Academy. Let's get started. These are four different identities we are going to do geometrically. Earlier we have done 6 identities. The video part 1 is already, if the link of that is given in the comment box, please check. We are doing the next one. Okay. So let's get, we want angle A and angle B, right? So we make that slightly bigger. I'll explain to you bit by bit and I draw. Okay. So we have this angle A here. Angle the bigger one, sorry, the bigger one is angle A and this is angle B. This is the bigger one, which is angle A, the smaller one is angle B. So what we are doing is, let us its size. This is angle B and this is angle A. Okay. Now, for angle, this is angle A and B, means this will be A minus B, right? This is the difference of the two angles. So this I am bisecting into two equal parts. So this will be A minus B upon 2. This will be A minus B upon 2. On the bisector, I am drawing a perpendicular. The perpendicular will be like this. Say, it's not so perpendicular. I just make it looking like one. Okay. So this is a perpendicular drawn to this bisector. So as per our symmetry, as per geometry, we know that this two will be equal. Because it's a perpendicular, so we have a isosceles triangle. It's the exact half of it, and we are making a bisector perpendicular to this. Automatically, it will be bisected into two equal parts. So this and this will be equal. So also this two. So we actually have an isosceles triangle treated. Okay. Now let's name them so it's easy for us. PQR. So we project them down. Every point is projected downwards. Okay. So let's call this as M, N, and L. This will be O. So what about this angle? This angle. This angle. This angle is B plus A minus B upon 2, right? This is A. B plus A minus B upon 2. So what is that angle? B plus A minus B upon 2. It is nothing but A plus B upon 2. You calculate, you will get this angle. Right? So this angle is A plus B upon 2. So I name this as A plus B upon 2. A plus B upon 2. So we have A minus B upon 2 as this, the small one here. Till here, this is A minus B upon 2. We have A plus B upon 2. So all the angles are in place. There's still more construction left. We just want to do like this. So let's call it S and T. Fine. Okay, now it's ready. Now if you watch closely, there are certain things happening over here. There are so many triangle properties involved. Understand this. If you consider this triangle now, PSR. In this triangle, we have a base P, assume this is a base, and a line passing from the midpoint of one side and parallel to the base. So as per the midpoint theorem, this line will divide SR into two equal parts. So ST will be equal to TR. So we have one thing. ST is equal to TR. These two will be equal. Right? Secondly, QT will be half of PT or PS. PS is equal to 2 times QT. Right here. PS is equal to 2 times QT. Both midpoint theorem. Okay, midpoint theorem. So this is what we get, right? There's something else. If you go to see this triangle, no, A plus B upon 2, look here, A plus B upon 2, this one, and if you look at this, suppose if this is A plus B upon 2 and you have, say, this one, this will also be A plus B upon 2, right? This will also be A plus B upon 2 because they will be corresponding angles. If this is A plus B upon 2, this is 90, this will be A plus B upon 2 minus 90. If this is A plus B upon 2 and this is 90, this will be A plus B upon 2. 90 minus A plus B upon 2, right? If this is 90 minus A plus B upon 2, then this will be A plus B upon 2 because, I'll tell you once again. Look, this is A plus B upon 2, this one. And this angle here, these are the corresponding angles. If you consider triangle QSR, this is 90 degrees, this is A plus B upon 2. So this will be 90 minus A plus B upon 2. And in triangle QTR, since this is 90 minus A plus B upon 2, this will be A plus B upon 2. Right? So we have another case where this is also a plus b upon 2. You check it out, you will understand this. Right? Now our things are ready. So we have already kept all the prerequisites to prove them. Let's see. Let's start with this sine a plus b plus sine b. What is sine a? Sine a is what? Opposite upon hypotenuse. This is my big angle a, bigger one. So it's Pm upon OP. So that's Pm upon P. Now this Pm, okay, here I'll hold it. I'll tell you what is Pm. Let's add this. This is one thing we did. Pm plus, let's add this Pm plus RL. So you understand RL. This is, we will need it, so I'm writing at the side. Okay. Pm plus RL is Ps plus Sm plus RL. Ps plus Sm plus RL. So the RL. Now RL is equal to Tn. RL is equal to Tn because this is a rectangle. RL is equal to Tn. So we have plus Tn. Sm is also equal to Tn, right? Sm is also equal to Tn. So I have plus Tn. What is Ps? Ps is equal to 2 times Qt. We already know, right? So this is 2 times Qt. So that's equal to 2 times Qt plus Tn. So that's nothing but, you see, Qt plus Tn is nothing but Qn. Q. So we have this is equal to this. Okay. Now we will need this here. Look at this. Pm upon OP plus sine B is what? And this opposite upon hypotenuse. What is that? B. RL upon OR. Now if you look, OP and OR are same. OP is equal to OR because they are isosceles triangles, sides of isosceles triangles. So they are OR. I will replace them with OR. Now I call them as PM plus RL upon OR. Okay. Now if you see here, what we have done, PM upon RL is equal to Qn. So sorry, this is 2Qn. 2Qn. So we got it as 2 times Qn upon OR. I write it as 2Qn upon Qn is here, so I divide by hypotenuse OQ. OQ into OQ upon OR. See what we get? We get it as 2 times Qn upon OQ. Qn upon OQ is nothing but a plus b sine a plus b upon 2, right? OQ upon OR. So in this right angle triangle, this is hypotenuse. So OQ is cos of a minus b upon 2. Check it, you will understand. So we have matched the RHS of the first identity derivative. So we have done this. Right? Okay, let's go for the next. Now second is minus. So I just have to put over here minus. The rest all goes. Till here we need. So I write here minus. Let's see what we get. Minus. Okay. Sin A minus sin B. Since OP and OR are equal, I write it as equal. What is PM minus RL? PM minus RL. Is it PS? Yes, it's PS. Now PS is equal to, we know it's 2 times QT. So 2QT upon OR. So I can write it as 2QT. QT is here. So I have this hypotenuse QR, right? QT upon QR into QR upon OR. What does it give us? 2 QT upon QR. QT upon QR is cos of A plus B, right? A plus B upon 2. QR upon what? QR upon OR. That's sine of A plus B, A minus B upon 2. That's sine. A minus B upon 2. So there we are getting. Getting the next one, right? So that is also equal to my RHS. Okay. Let's move on. Let's go for the third one. Okay, let's do the third one. Cos of A plus B. Cos A plus cos B. Sorry. Cos A plus cos B. That gives us what is cos B. We have A1. That's OM upon OP. That's OM upon OP plus cos B. B is here, so OL upon OR. Right. So since OK and OR are same, I'm keeping it as OR. So that's upon OR. So what is OM plus OL? Let's see. OM plus OL. Okay, here I do that. OM plus OL. Can I say OM plus OL is equal to OM is equal to OM plus OM plus OM plus OM plus NL plus NL. MN plus NL. Okay, I'll say this. MN plus NL. Now, instead of saying MN plus NL, can I say 2NL? I can say 2NL because both are equal, right? Both are equal. These two are equal, so definitely these two are equal. These two are also equal. They're projected downwards, so they are also equal. So I can call it as 2 times OM plus NL. So that's equal to 2 times. What is OM? OM plus NL. Okay, I have to say MN, right? MN because it's not NL. MN. N. So it's MN. So 2 times OM plus N. OM plus MN. That's equal to 2 times OM. So 2 times O. I'll say this once again. Maybe I was too fast. Understand this. OM plus OL is what we want. OM plus OL is what we want. OM, in that already OM is there. This is the same OM I have taken. OL is what? OL is OM plus MN plus NL, OM plus MN plus NL. I wrote it as MN only because both are equal. So I wrote 2 times MN. So that gives me 2M. So I make 2 common out. So OM plus MN gives me 2 times OM. Right? This is what we get. So I replace here 2 times OM. So we are nearing that right side. Let's check. That's equal to 2 times OM upon OM कहाँ है? OM upon OQ is it? OQ into OQ upon OR. That gives us 2 times OM upon OQ. OM upon OQ is, we have it as a sine of A plus B upon 2. Yes, get sine A plus B upon 2. OQ upon what? OQ upon OR. That's cos of A minus B upon 2. Is it easy? There, it's correct. Third one, sorry, we got this here. ON upon OQ. Sorry. This is cos. That's the way of 2 cos A plus B upon 2. Cos A minus B upon 2. Okay, this is cos. Right? So we have made the RHS. Okay, let's go for the last one. Cos A minus cos B. A minus cos B. So here, cos A is what? A. That's OM upon OB. Minus cos B is OL upon OR. This is very easy. See? OR only I'll keep because OP and OR are same. OM minus OL. OM minus OL. Okay, that's negative. OM minus OL. It's minus ML, right? Instead of saying minus ML, I'll write it as minus ML. What is it say? Can I say minus 2 times ln? Or can I say TR? ln, 2 times ln upon OR. Or I can even say minus 2 times ln same as TR. Because I am working on this triangle now. On OR. See what you get? That you get it as minus 2 into TR. Yeah, let's divide it by TR is here, so divide by QR. QR multiplied by QR upon OR. Where does it take us? TR upon QR is what? TR upon QR. That's sine of A plus B upon 2. Minus 2 sine A plus B upon 2. QR upon OR. QR upon QR upon OR. That's sine of A minus B upon 2. Yeah, correct. So this is also my RHS. Students, this is the way you do it. Please, you can try yourself, get to know more about it.